What is the buoyant force on a rectangular block of wood that measures, and this is all centimeters, right? If it's submerged in the Dead Sea. Now, to be sure, this thing is going to want to float like heck, right? So we're going to have to hold it under. Maybe it's being held to the bottom with a string or something like that, right? And we just want the buoyant force on it. So we don't even know the weight of this block, right? We just want to know what is this buoyant force on it, right? So the buoyant force is the density of the fluid, right, times the volume of the fluid displaced times g, right? And the density of the fluid displaced, this is amazing, right? In the Dead Sea, remember seawater is 1,025 kilograms per cubic meter. Dear Lord, this has 240 kilograms in a cubic meter of extra stuff, right? That's just amazing. All right, okay, so let's do this. Okay, so the density of this fluid is this, right, the 1,240 kilograms per cubic meter, right? The volume displaced is, and then turn this into centimeters first. So 0.12 times 0.23. We're just doing length times width times height because it's a rectangular solid, right? Times 0.15. And then times 9.81. Okay, so 1240 times 0.12 times 0.23 times 0.15 times 9.81. And I get 50.36 newtons of buoyant force. Now, keep in mind this thing actually could weigh something, right? There could be maybe a force of 20 newtons down, right? Or something like that. Who knows what this wood is made out of, right? But there's definitely 50.36 newtons up. Okay, which I guess with 2 sig figs is just 50 decimal point.